Hello, welcome back, and this is homework 8, exercise 10. For this question, we are going to prove that if a normal process is y-sense stationary, then it is strict sense stationary. So that is normal process is WSS. We need to prove that it is SSS. So what is SSS here? So if a sequence is strict sense stationary, then if there is a time shift epsilon to the t, so fxt still equals to fx t minus epsilon. So that is SSS here. And here, based on the slide, we have an expression here that is this C here is the auto covariance matrix, and DT is the determinant of this matrix. So here this auto covariance matrix is equal to this, and here X is matrix here, x1, x2, xn here. That is like this. There are matrix here, and here that is why we have this transpose of this matrix. And we could expand this expression to this second step. So that is xt1 minus the mean value of xt1, and then here there is n terms here, and the last term here xtn minus the mean value of xtn, and times this matrix transpose of this matrix that is here. And so we know that this process is WSS, so the expected value of xt is a constant. We could define it as a eta here. So xt1, mean value of xt1, mean value of xtn, they are all eta here. And then we could write it. Let me to write more detail about this step. So the first term is mean value of xt1 square plus mean value square of xt1, right? And minus 2 times xt1 mean value of xt1. So the first term here, that is the auto correlation of t1 and t1 here, right? And the second term, the mean value of this mean value square, that is eta square. So the mean value of eta square is still equals to eta, so that is plus eta and minus 2 mean value of xt1 times eta, that equals to 2 eta square, right? Minus 2 eta square here, that is equals to minus eta square. So that is how this minus eta come here. And for the other terms, we just change the parameters of this auto correlation here. So the first row and last column of this is t1 tn minus eta square, and yeah, I think that is easy for you guys. And for the next step, we could replace the parameters with the time interval of these two times. So the first is t1 minus t1 equals to 0. So we write 0 here, and that is t1 minus tn. Yeah, I think that is not difficult, right? So yeah, then to sum up, we could simply write this auto covariance is equals to all those terms, that is ti minus tj, right? Since you could find all those terms are these two intervals minus and together, we get this term here. So we know that this density function of this process is equals to it, and we could write it as it equals to this. We replace all the t1 to tn with ti minus tj. And since we are gonna to prove it is as we need to give a time shift to t. So here, that is time shift epsilon here for every t, and t1 plus epsilon, t2 plus epsilon, and to tn plus epsilon. Then from the previous step, we know that it equals to ti minus tj, but at this time we have a time shift epsilon here, and we minus these two time shift, that is equals to 0. So for the result, it is still equals to ti minus tj. That should be ti, and y is 1 here, and it is equals to this original expression, so that we prove it is strict and stationary.